I believe you can see my presentation, right? I guess so. Just to give you an idea of my background, I have a longer background on REST services and REST APIs. So I was basically working for a startup in the API management field that got acquired by Red Hat, and now I'm working with let's just say integration technologies. So I'm basically looking at the different ways and protocols that you can use to basically let two systems communicate with each other, and that's one of the reason I started getting interesting to GraphQL. So bear with me, I'm not a huge expert in GraphQL, but I'm trying to get the speed up on some details on this. But what I'll present today is really around a general overview of what are the challenges of GraphQL as compared to your typical REST API, possible solution to a specific issue. Then we'll see a demo covering a specific problem, and then we'll have time for some Q&A, basically. So starting just from the basics, I'm pretty sure you all know a little bit the definition coming from the organization website. What I highlighted for my own, let's just say for my own understanding and my own guideline is what are the peculiar and very important aspect of this as compared to your typical REST service. So in this sense, GraphQL is both the query language and the runtime, and it provides a fully understandable and complete description of the data. So this means that it offers really a powerful contract between what is the client and the server. This also means that in some sense, it can be compared to SOAP and to the way SOAP used to work. And most importantly, it allows for always evolving API as compared to what happens with REST APIs and with the API definition. So from all of this, you can see that you get greater power as a developer and also as an end user, because you can basically build your own query. But this also comes with greater responsibility. So this is not from originally from Spider-Man movie, but it's actually from Voltaire. And this is very true because you can basically build whichever query you want, and this gives you potentially access to the whole backend. So this is one of the very important aspect that differentiate this from your typical REST service. So basically, we're switching from this approach to this one, right? As you can see, GraphQL is really language agnostic and is also protocol independent, so it can run also over not only on HTTP. Let's just go through a little bit of what are the advantages that I was mentioning also at the beginning. So first of all, of course, the exact data fetching. So as we can see, oftenly with REST services, we generally run into an underfetch or overfetch problem. So the client might get not all the result he expects, while interrogating the REST service, or get too many results, meaning too many details that are really not needed with the query. In this case, you can build your own specific query and get exactly what you need. This is also very important in terms of mobile client, of course, because you can fetch exactly the needed information, meaning less payload through the wire. The other important element related to this also is with one request, you'll get a complex or composite result, which also result in higher network efficiency. So it's highly related to the previous one. And this compares to what happens typically with a REST API, where you need to build multiple queries to get a composite result, and you might even need to have an integration in between your REST API and the actual client to actually rebuild the result. This is also highly inefficient because you're running multiple queries, and sometimes you might not even need all the single items inside the list. The other advantage is also the fact that given that you're allowed for schema stitching and you can build a general GraphQL schema, now the same API is usable by multiple clients with different queries. This is super important because the typical approach for REST services is actually multiple APIs for an omni-channel approach, or multiple API gateways. So this again, coming from the REST world, is one important highlight. And finally, the field level deprecation. So a topic that I was often discussing with customer across the world is the approaches to versioning, to deprecating certain resources inside an API, and in general, how to keep the documentation update while you're developing a new version of a REST API. So unless you have a really well-oiled CI/CD pipeline with end developers actually respecting the rules around publishing open API specification, then some specification will fall into the crack of this, and some developer will see a version of the API which is broken or returning an unexpected result. So with GraphQL, you can actually deprecate single fields, which means that it's way easier to manage new version because you're really evolving the schema continuously. And given also how important or how central is the schema in the whole architecture, that's always up to date. Of course, having a single endpoint basically as an entry point has some issues. So these are some of the challenges that you will run into when you're starting to expose a GraphQL service. Some of them have already been tackled through workaround or are being tackled. So, for example, caching with REST, of course, you get different resources mapped by different URLs, which means that you're able to cache at a resource level. In GraphQL, this is more complex because you don't really know the query before it's getting executed. And but for this, I believe there is already some solution. So preloading or prefetching the data might help you here. Then you have in general the issue around query performance. So you might want to in some way limit the depth of the query, because it could be that once you're opening your GraphQL service to the external world, you get random users, of course, and this might decide to just see how reliable is your backend, and might even bring your system to knees if it's not well built, let's just say, or in HA. Then we have security. So the whole OpenID Connect and OAuth authorization and authentication is quite tightly coupled, I would say, with the REST architecture. And there's a whole set of RFC that might not be as easy to apply to a GraphQL service. At the same time, you also have rate limiting, which typically comes with an API management solution, which might not be as granular as in the case of an exposed REST service. And finally, performance monitoring. So typically, if we just measure the GraphQL endpoint, the response time of it, we don't really get a lot of insight into what's the actual health status of our API, because basically the query can vary a lot, and we don't really even know the backend here. So let's just give you a little example. So imagine that we have an internal user or developer that's just executing a simple query, as we see here in the first case, and now public developer comes in and we exposed our GraphQL API externally, and really he wants to retrieve the first 1,000 friends. So clearly the two queries are not really that different as we've seen in the structure, but the second one will most likely see a much higher response time. And of course, response time might be determined by the complexity, but not only of the query, depending on where is the data coming from. So for example, if it's coming from different tables, if we are mediating SQL, or it is coming from different sources. So it might even be coming from a database and a file. So in general, what we're really looking for is the standard behavior given a comparable workloads in terms of queries. So we're really interested into monitoring not the endpoint, but the queries. So here comes the topic of performance monitoring in this sense. So in terms of REST monitoring, typically we speak about observability. So this is defined as the ability to determine the internal state of a system by looking at just its external outputs, so without knowing a lot of its internals. And it basically, in practice, in software, it consists of three pillars: so metrics, traces, and logs. So once you draw the information from these three sources and combine them together, you're basically able to troubleshoot much faster and find bottlenecks in your code or in the calls. And so getting back to the three pillars, so we're gonna focus on traces. Distributed tracing is basically a way to that's used typically in microservice architecture to actually pinpoint where a failure or a delay is occurring in the chain of calls. And open tracing is an open approach to distributed tracing. So it's basically it's an approach where you have a set of API specification, frameworks, and library, and you basically, as an end developer, you can instrument your application with these libraries, which are using these APIs to actually implement open tracing, and then use the tools you see here on the right-hand side to actually perform or analyze the tracing of your microservices or applications. So just a brief digression, maybe you have heard about open tracing or open census. They now recently merged to form open telemetry. So basically, you will most likely hear in the future just about open telemetry. Just a quick news. So one of the tools that we saw here that is actually implementing the open tracing API as a monitoring tool or monitoring platform is Jaeger. So Jaeger is a product that was built at Uber. It was donated to CNCF and has a lot of libraries supporting several different programming languages. It also accepts spans, so basically traces from Zipkin, which is another distributed tracing platform. So this, to give you an idea, is an example of the Jaeger platform exploded. So you typically have your own application, the Jaeger client. So this is the library. So this is actually let's just say a containerized example. So in this sense, the Jaeger agent, which is the one collecting the traces, is actually running inside the same container, but it could be running outside. And the Jaeger agent is receiving the spans, so the traces generated by this client, this library, and is then sending them to a Jaeger collector according to a specific or configured sampling. And then eventually you have the aggregation of this into a database, and then you have a query engine that runs on this consolidated data source with a UI where you can actually visualize the precedence and the timeline of the different traces. So just to give you an idea, this is how it works in practice, so how the traces are generated. So this is the library. In this case, you receive an HTTP request, and you basically you're adding a trace ID to the header of the request, and just basically extending the trace. So that it's all the systems or the application in the chain will collaborate on the same trace ID. So possible way to actually implement tracing inside GraphQL are available. So the first one is a little bit or tightly related to actually your runtime or for GraphQL, so in this case Apollo. And there is an extension that allows you to actually perform tracing directly inside the response. So as you can see here, for example, this is part of the response, and I'm getting data about how long it took to get part of the query. Then you have the possibility of using Instana. So we will see that we have other typically cloud tools here for monitoring. So this offers out-of-the-box tracing for GraphQL on several programming languages, and you are able to explore the traces inside the monitoring dashboard. Then you have Datadog, which provides open tracing or tracer library, which is compliant with open tracing. So this not only covers GraphQL but other protocols and technology. And then you have New Relic, so this is similar to Instana approach. Again, you have the possibility of drilling down into the query and actually checking the distributed tracing information. And finally, so this is what we'll actually see today in the demo that's coming up. You have the possibility with Apollo to use a plugin which is compatible with open tracing. So you will find this on GitHub, and request and field resolver are traced out of the box, and queries and results are logged. You can also customize completely the behavior according to what fields or what requests do you want to trace. This is, as I was mentioning before, open tracing compatible. This means that you're not forced to use any specific tracing monitoring platform in particular. So today I'll be using Jaeger, but you could be using Zipkin, for example. So, quick intro about the demo. So, Apollo Server is basically an open source GraphQL compliant server, and it can be run as a standalone or as an add-on to Node.js middleware. So in my demo, I'll be using Apollo Server with Open Tracing plugin, React.js client, which is also using the Apollo client libraries, and then the Jaeger platform, which we saw before. So this is basically the architecture of what we will see. So I will hit the local page from the React.js client. This will hit the Apollo server, which will use Axios to actually translate the GraphQL query into REST queries towards the GitHub REST API. And in the meantime, I will be sending the traces to a local Jaeger platform I'm running on my machine. So all of this will be running on my machine, with the exception, of course, of GitHub. Okay, let's switch to the demo. So I have my React.js page here. Let me just stop the Apollo server. Let me start again this. Hopefully the demo gods will assist me. Okay, so we see that I initialized Jaeger tracer. I have the server ready, and my client hopefully should be ready. It is. So I will hit this. It is loading the result, and it is loading and presenting some GitHub user. with the avatar and the user ID and the link to the user profile. So if we go back to the server, we can see that we generated, beside the GraphQL response, we generated spans for each of the user that was for each of the user and the field that was interrogated, and we can see this inside Jaeger. So if we go back to find traces, yeah, this is from right now, basically. So we can see here, if we expand, that we have the root trace with the request and the query with the called users, and then the different field used in the query. And clearly we can see that it took quite a long time, because it is basically sequential, so it's calling the REST API multiple times. So again, we can see the advantages of actually using GraphQL also for your backend instead of using for a composite result REST APIs. And as you can see here, we can see how much time was spent on each of these fields. So this is quite useful if, for example, besides tracking and tracing the GraphQL endpoint, you're also tracing the actual backend. So in that case, you would be able to see where the latency is coming from. And just to give you an idea, some messaging platform like Kafka and RabbitMQ are already supporting distributed tracing. So if you use that as a backend, and I believe also some databases are also, you can instrument them with the open tracing libraries. Sorry. So this is, I just explained what happened in terms of the actual flow and what were the calls. And so let's switch back to feedbacks and comments on this.
Thank you, Luca, for the presentation. Let me quickly check if we have any questions. I think there are no questions, but so I will have one, maybe not a question, but rather a comment. So first of all, very comprehensive presentation, like covering also some of the good things and bad things about GraphQL, as well as the all performance topic. So I can just comment that we at Sailor, in our e-commerce platform, we do use Datadog currently in production, and I think it's working really well for us. And in the past, we were also using, like, locally for the dev team, Jaeger for example, optimizing the database. So we were using that to show what were the database requests and if there are any duplicated requests, and that would help us to optimize that. So we currently use those two tools. I wanted to ask if you have any experience with Apollo engine, or if you heard about that one.
No, I know. So you mean the analytics through the Apollo, like, enterprise version, I just say?
Yeah, I think, yeah, this one. So I haven't used that, but I know that Apollo has their own platform for performance, the Apollo engine, and like they had this dashboard where you can actually see what queries are used in your front end, or you can see if there are, like, which queries are used the most often, which are not used. So you can learn if, for example, a query can be, deprecated in the future or how often it is used, stuff like that. And there was also very nice integration with VS Code editor, where you could have from Apollo Engine in your editor estimated time of a request when fetching a query. So this was pretty powerful, but I've never used that. So I was just wondering if you have any experience with that.
I don't. I try to set that up. You basically have to, as any of those tools, provide a key to authenticate to the service in the cloud. What I like. Oh, okay. We got a question actually.
Yep.
Let me just finish. Yeah. So honestly, coming from a Red Hat and open source perspective, I like much more the open tracing approach, because then you can move Jaeger on-prem if you want, and then manage everything locally. Maybe it's not as complete as the information you would get by a specialized tool on GraphQL, but at least you get flexibility in that sense.
Yep. Yeah, so we have one question. Is there a tracing tool that can be integrated with GraphQL Ruby? Do you have anything about that?
Exploring that, actually, I believe Ruby has their own libraries around GraphQL and open tracing. So you could be using directly that, and basically what you're doing is you're configuring a tracer inside Ruby, and the tracer is inside basically your GraphQL backend, and then it sends the trace directly to Jaeger.
So I think that you only depends on the framework, because I'm not familiar with what are GraphQL frameworks in Ruby. I'm only familiar with JavaScript and Python. But I think that like open tracing is a very general protocol, and it should be available in many technologies, right? So it's just a manner of integrating open tracing basically, and you should be good to use all of those platforms like Datadog and stuff like that, right?
Yeah, you should be able to, although it depends on how flexible it is the library in terms of where you're starting your trace. So if you can pick up the field in the query, for example, or not, because for sure you can pick up the general HTTP query, but then you want to detail about the fields, right? So
yeah. Okay, so I think that's it. So thanks again for your presentation, and I encourage you to share the link or either on Meetup or with us, and we will share it with the community. So thanks for the presentation.